Welcome back, everyone. I'm putting together this short video from our 4.1 calculus class where we have to find the particular solution to the differential equation, which is just short for we're going to find the C value after we're done integrating. So a couple things we need to know. We're going to start with a derivative and work backwards with our integration technique that we've learned of the power rule, raising the power by 1, dividing by the new power. But the thing that's going to be new now is that they're going to give us a point, an initial condition, so to speak. This initial condition will come into play to help us to solve for C. So when we do that, I'm going to change color here real quick. We're going to integrate both sides. And when we integrate both sides, the antiderivative of the derivative, what essentially happens here, it bumps us down 1. So we go from y prime down to y. And then our power rule here, raise power by 1, divide by the new power. This will get us x cubed plus x plus c. Now, knowing that this is x and y, we are going to plug in x and y and help us solve for c. So 4 is going to go in here, 2 cubed plus 2 plus c. So this is going to be 2 cubed, 8 plus 2, that's going to be 10. So 4 equals 10 plus c. Therefore, when we subtract 10 from both sides, we're going to get c to equal negative 6. So now this is what we did at the beginning of the chapter. This is our general solution. And now we're going to find a particular solution. And so now all we have to do is put that negative 6 in here, and we'll have y equals x cubed plus x minus 6. That's the particular solution to the differential equation that we started with. Now, a couple things to note here. We have y prime. That could have also been dy dx equals, no big deal there. Our point, this is our general point here of x comma y. They could have also written it in function notation. Could have been the same thing there of x and y when we did that. Okay, so let's look at another quick example. We've got dy dx equals 8x cubed plus 12x plus 3. Our initial condition, our initial point here is 1, 6. We're going to integrate again. So we'll get y equals, raise the power by 1, divide by new power. We'll get 2x to the 4th. Raise power by 1 here. That'll be squared, and divide by 2. So we'll get 6x squared plus 3x, and then plus c. There's our general solution. Now again, we're going to plug in the x and the y. So 6, 2 times 1 to the 4th, 6 times 1 squared, 3 times 1 plus c. So that's going to be 6, 2 plus 6. Whoa, what happened there? 6 plus 3. So 8, 9, 10, 11. So 6 is going to be equaling 11 plus c. So therefore, c is going to equal negative 5. So our particular solution is going to be y equals 2x to the 4th plus 6x squared plus 3x and then minus 5. Now for those in my class, when we do the delta math, you have to put the y equals. You can't put just the equation. You got to have it set up that you have y equals and you put the whole answer in there for a particular solution. And then we're going to do one more example. Here we've started with the second derivative. All this means is you're going to have to do it twice. Okay, so let's actually, we'll use green on this one. We're going to integrate the second derivative. When we integrate the second derivative, that's going to get us the first derivative. And then we got 2x plus c. Now, if you notice, we have an initial condition here for our first derivative of 2, 5. So I'm going to have 5 equals 2 times 2 plus c. So 5 is equal to 4 plus c. Therefore, c is going to equal 1. So that means then that our first derivative was 2x plus 1. And then we got to do it again. So we're going to integrate again. Integrating y prime bumps us down to y. 2x will be x squared plus x plus c. And then we have to use the initial condition for the original function, which is 10, 2 squared plus 2 plus c. That's going to be 6 and plus c here. So therefore, c is going to equal 4. So that means that our original find f of x, we're going to have y equals x squared plus x plus 4. There is our particular solution, starting with the second derivative, and we had to do it twice. So very quick video, but hopefully that'll help you out there on just reviewing there for finding C from our first section there of 4.1 in our calculus class. Thanks for tuning in.